All right, let's go. Number 8. The Hartle-Hawking no-boundary proposal. Every theory about the Big Bang's cause connect the same wall. The moment you ask what came before, you assume that time already existed before the beginning. What if asking what caused it is as meaningless as asking what's south of the South Pole? The no-boundary proposal radically reimagines time. In ordinary life, time is an arrow, a straight line stretching infinitely in both directions. But Hartle and Hawking proposed that near the Big Bang, time was not a line. It was behaving like a spatial dimension. To make this mathematically tractable, they introduced imaginary time, a mathematical rotation where time and space dimensions become geometrically interchangeable. In imaginary time, the universe has no edge, no boundary, and no beginning. The Big Bang wasn't a blast. It was a smooth, clean shift, where imaginary time crystallized into the reality we know. We crave a why because we're trapped in linear time. But before the bang, time was zero. The universe needed no creator. Number 7. Vilenkin's tunneling. In 1982, he proposed the universe didn't evolve. It just popped into existence from absolute, literal nothingness. Quantum tunneling is the key. Particles don't climb walls. They teleport through them. Our entire universe might be a quantum jump. Nothingness is unstable. Like a radioactive atom, it eventually decays. And in that cosmic breakdown, a whole universe is born. Number 6. String gas cosmology. Imagine the beginning as a cosmic knot of strings, governed by the mind-bending rules of string theory.
T-Duality is the secret. It proves a microscopic universe is mathematically similar to a giant one.
There's a floor to how small reality gets. The Hartle-Hawking proposal is mind-bending, but Alexander Vilenkin took it even further. He suggested the universe tunneled from absolute nothingness. Imagine a state of literal nothingness. No space, no time, no energy. Just a mathematical potential waiting to be realized. To understand this, look at quantum tunneling. A particle trapped by a barrier it shouldn't be able to cross. The spark in the void. In classical physics, that particle is stuck. But quantum mechanics tells a different story. It doesn't need to climb over. Because its position is a probability wave, there's a tiny chance it just appears on the other side. It's a ghost-like transition. Vilenkin applied this to the whole universe. Our reality tunneled into existence, bypassing the need for a prior cause. But if tunneling feels too strange, consider string gas cosmology. It suggests the universe started as a tightly marked knot. The universe in imaginary time has no sharp starting point. It simply curves back on itself. Number 7. Vilenkin's tunneling from nothing. In 1982, Alexander Vilenkin proposed something audacious, the universe curving back on itself. He suggested our universe didn't evolve from a prior state, or a quantum vacuum. It didn't bounce from a previous cosmos. It tunneled, instantaneously and without a cause. It came out of absolute, literal nothingness. To understand this, look at quantum tunneling. The universe tunneling from nothing. In 1982, Alexander Vilenkin proposed something so audacious it bordered on metaphysical. He suggested our universe didn't evolve. It didn't emerge from a quantum vacuum or bounce from a previous cosmos. It tunneled, instantaneously, out of absolute, literal nothingness. To understand quantum tunneling, imagine a particle trapped inside a potential barrier, an energy wall it classically cannot cross. In classical physics, it's imprisoned. But in quantum mechanics, the particle's position is a probability wave, not a fixed point. There's a non-zero chance it simply appears on the other side. It doesn't travel through the barrier, it just exists there. This position is described by a probability wave. There's a mathematical chance the particle just appears on the other side. It doesn't travel through the barrier. It ceases to exist on one side and begins on the other. This is a confirmed phenomenon. This quantum tunneling powers the nuclear reactions inside our sun every single day. It's a fundamental part of our reality. In quantum cosmology, this state of nothing is unstable. The wave function has a non-zero amplitude on the other side of the barrier. Imagine the universe just popping into existence from absolute nothingness. No history, no ancestors, just a sudden, brilliant quantum leap. Everything we know, space, time, matter, erupted in a single moment, much like a radioactive atom decaying without any warning or trigger. Vilenkin's theory suggests that nothing is actually unstable. It's like nature abhors a vacuum so much that it creates a whole universe. The Big Bang wasn't a choice. It was an inevitability born from the quantum instability of non-existence itself. It had to happen. Nothingness simply can't stay quiet forever. And that leads us to our next mind-bender. Number 6. String gas cosmology. Forget the fiery energy burst for a second. What if the universe began as a tightly marked ball of cosmic strings?
Physicists Brandenburger and Waffe proposed this stringy start.
Using a mathematical mirror trick they call T-Duality to explain the beginning. In standard math, points cause problems. But strings? They have energy modes that keep the universe from breaking at its birth. Vilenkin's mind-bending theory suggests the Big Bang was born from the sheer instability of non-existence. Turns out, nothingness just can't stay quiet forever. Number 6. String gas cosmology. Most theories assume we started with a chaotic, hot energy burst. But what if the truth is far more constricted? Imagine a universe starting from maximum constriction, ruled by a bizarre physics that only the elegant math of string theory can actually explain. Brandenburger and Waffe's string gas cosmology swift move off with a unique, game-changing principle called T-Duality. It changes everything we know about scale. Standard physics says if you powerful force space into a tiny point, energy density goes infinite. That's a singularity, and where the math usually breaks down. But here's the twist. Strings aren't just points. They have a physical size that prevents the universe from ever reaching that infinite breakdown. A string wrapped around a tiny dimension has two energy modes, its own vibration and the energy of how many times it's marked up. Vibrational energy is the string's internal hum, while winding energy is the tension from wrapping around space itself. Physicists Robert Brandenburger and Kumrun Waffe proposed a universe born from a dense gas of strings, not a bang.
The vibrating string.
They used T-Duality, a principle where a massive universe is physically similar to an incredibly tiny one. Whether the radius is r or 1 over r, the physics remains the same. Size is relative. Unlike point particles, strings can't be powerful force into a singularity. They have an inherent, unbreakable size. Winding energy comes from strings wrapping around space. As space shrinks, this energy pushes back fiercely. This creates a cosmic barrier. The universe can't collapse further because the winding energy becomes too great. This is the Hagedorn phase, a hot, static tangle of strings where time and space seem to stand still. Cosmic stalemate. The string scale is the ultimate floor. Below this, the universe simply mirrors its larger self. Our own genesis was sparked by the dramatic moment of a giant star in a universe completely inaccessible to us. Number 4. Causal dynamical triangulation. Every theory of the Big Bang faces a crisis. General relativity and quantum mechanics are incompatible. To describe the origin of the universe, we need both simultaneously. Gravity at its most extreme, operating at quantum scales. This breakdown is the singularity problem. The equations simply stop working at the very moment we need them most. CDT attempts to solve this by rebuilding the very fabric of space-time from the ground up, using quantum building blocks. In CDT, spacetime isn't smooth. It's built from tiny 4D blocks called simplices, like cosmic Legos. Each simplex has a built-in direction of time. This prevents the clean chaos of earlier models. Simulations show these blocks self-organize into the smooth 4D universe we see today. Space-time is emergent. Now, imagine the Big Bang wasn't an energy burst, but an eruption from a white hole. A white hole is the mathematical reverse of a black hole. Nothing can enter, but everything pours out. While black holes swallow stars, white holes spew matter and energy into the void with incredible force. The link? An Einstein-Rosen bridge, a wormhole connecting a falling star in one universe to the birth of ours. Our Big Bang was the output valve of a cosmic pipeline, recycling debris from another reality into our existence. The Big Bang was a phase transition in quantum geometry, a spontaneous reorganization of Planck-scale building blocks. It shifted from a state of chaotic, crumpled geometry into an ordered, smoothly expanding spacetime. The Big Bang marks the boundary between two phases, the disordered quantum foam and the structured, expanding universe. We didn't start with a bang. We began with the universe crystallizing into coherence. Number 3. White hole eruption. General relativity permits a variety of bizarre, clean configurations in space-time. Smolin's theory turns the graveyard of matter into a cosmic incubator. What if singularities aren't ends, but ruptures? Cosmological natural selection suggests universes that generate more black holes will have more offspring. It's cosmic evolution. Fundamental constants like gravity and light speed are subtly altered during each birth, fine-tuning the multiverse. Our universe is incredibly efficient at building black holes, implying we're part of a sprawling family tree. Every theory faces a crisis. Relativity and quantum mechanics are incompatible. Forget energy burst. CDT builds reality from scratch using quantum simplices. Think of them as the 4D plastic block-style bricks of the universe. Unlike chaotic models, these bricks have a built-in arrow of time, ensuring every before leads to a perfect after without clean madness. When we simulate billions of these bricks, they don't just sit there. They spontaneously assemble into the smooth, 4D spacetime we call home. The Big Bang was actually a cosmic crystallization, where chaotic quantum foam froze into the coherent reality. Number 3. White hole eruption. If black holes are the universe's ultimate trans, imagine a region where nothing can enter, but everything, matter, light, and pure energy, is violently vomited out into the cosmic void. Connected by a wormhole, a black hole in another universe could be the secret feeder, funneling everything it eats directly into our own. Our Big Bang might just be the output valve of a cosmic pipeline, spewing recycled debris from an older universe into a brand new one. Number 1. Holographic projection. This theory suggests the Big Bang wasn't an energy burst, but a massive processing event. The holographic principle shows that a black hole's information is stored on its surface, not its volume. This implies our entire three-dimensional universe might just be a projection from a distant two-dimensional boundary. Every star, every galaxy, and even time itself could be encoded as bits of information on a cosmic screen. When we apply this to the Big Bang, the narrative shifts from physics to a cosmic decoding process. Imagine a dormant sea of raw, two-dimensional quantum data. No space, no volume, just pure information waiting to be read. Then, a cosmic phase transition occurs. The math initiates a rendering sequence, like a giant projector turning on. Suddenly, flat information projects outward, weaving the illusion of three dimensions and the forward march of time. The intense heat and rapid expansion weren't physical collisions. They were the execution of a complex cosmic algorithm. The Big Bang was the moment the projector sparked to life, translating data into the reality we touch. Galaxies form in the light. Imagine a dormant substrate of raw, primordial, two-dimensional quantum information. No space, no volume, no arrow of time. Then, a phase transition occurs within the data form. The mathematics initiate a rendering sequence. The flat, static information begins to project mathematically outward, weaving the illusion of three spatial dimensions. The intense heat, the rapid expansion of inflation, were not physical collisions in a void. The 3D wireframe was expanding. They were the highly complex execution of a cosmic algorithm. The Big Bang was the moment the projector turned on. It translated a dense field of raw data into the rich, volumetric reality we interact with today. We are the active, continuously processing manifestation of boundary mathematics, playing out across a holographic theater. This cosmic projection sparked to life 13.8 billion years ago, and we are the living code within it. Number 1. Holographic projection. This is the most radical departure from traditional physics yet. The holographic principle suggests that all information in a volume is encoded on its boundary surface. Think of a black hole. Its entropy is determined by its surface area, not its volume. That's the principle. This implies our entire 3D universe might just be a projection from a 2D boundary. The Big Bang wasn't an energy burst. It was the start of a massive cosmic decoding process. Think of the universe not as a stage, but as a grand calculation, a cosmic algorithm running since the beginning. The holographic principle is wild. It says our entire 3D world is just a projection from a 2D boundary. Black holes proved it. Their information capacity depends on surface area, not volume. The surface is the source. So, every star and galaxy is like a hologram. We're just the 3D output of data stored at the edge. The Big Bang? That was the ultimate power-on moment. The cosmic projector started decoding the raw data of existence. Before the on switch, there was no space or time, just a silent, flat field of pure quantum information. Then, a massive phase transition's swift move off the rendering. Depth, gravity, and time's arrow were suddenly woven into being. We're living in a 13.8 billion adult holographic theater, a beautiful, complex dance of boundary mathematics playing out in 3D.